Hi guys, this lesson we're going to look at just a nice short lesson on this particular syllabus point for the Edexcel people. So explain the uses of aluminium, copper, iron, steel in terms of properties. Steel will be limited from low carbon to high carbon to stainless steel. So unfortunately, it is a memory aspect that you have to know. So if I just go through them once. Aluminium, we know is used for airplanes, but it's also used for electricity cables and pans. And that's the reason it's used for airplanes is because it has a low density and a high strength to weight ratio. It's also a good conductor of electricity. And surprisingly, it's resistant to corrosion because it is so reactive that it forms an aluminium oxide layer on top of the aluminium very quickly. So it stops the rest of the aluminium coming into contact with water or oxygen. Copper is less reactive than hydrogen, so it's used in water pipes because it cannot react with water. It's also malleable, and it's a good conductor of electricity and heat due to its delocalized electrons moving. So it's also used in electrical wires. It is ductile. It is easily stretched into a wire. Now, the different ions, the different steels, we can have mild steel, which is iron. It's an alloy of iron with carbon 0.25%, which makes it harder and stronger than the pure iron, malleable and ductile. And it can be used in nails and car bodies and ships. But obviously you need to use rust prevention because it can corrode. High carbon steel is more resistant to wear and tear. It's less malleable and less ductile. Because it has more carbon, it's stronger. So it's used in cutting tools. Stainless steel is an alloy with chromium and nickel. Now this one is extremely resistant to corrosion. So we can use it for our kitchen utensils, gardening tools, beer brewing, and the chemical industry. So this is the summary. I also have like another version of it here with like minimal words if you prefer. So I've got stainless, low carbon, and high carbon steel. And I've got the copper, the iron, ornamental usage, soft and malleable. And lastly, we need to consider what's an alloy. So an alloy is a mixture of a metal and another element, usually another metal or carbon. Now, some people make the mistake of saying that an alloy is a mixture of metals. It doesn't have to actually be two or more metals. It can be a metal with carbon, which is a non-metal. So this is the proper definition. And the key thing is that alloys are harder than pure metals because they contain different sized atoms that disrupt the layers and the layer structure. So the layers of the particles, the cations, cannot slide over each other as easily. That's the principle there. It can be a 3-mark question. So this different sized atoms disrupt the structure and the layers can't slide over each other. It's quite a bit going on there. And that's all explained for you here. So if you look at a normal metal, when you push it, the layers of cations will slide over each other. Make sure you say layers of cations, don't just say layers. Obviously, cations are these positive ions. Now, if you have an alloy, you have a different sized atom stuck somewhere in it, so it's a mixture. It's not chemically bonded, but the structure is disrupted, so it's harder for the layers to slide over each other. And that's why it's less malleable and stronger. Now, brass is a mixture of copper and zinc, and bronze is a mixture of copper and tin. So that's that. We're going to end the lesson here. Just learn these. It'll be a shame to lose easy marks. And join me next time. Thank you.